And then it does those boosted, sorry, go ahead.
I was just gonna say, we only had so much time to experiment to begin with.
Yeah.
So, if I saw that that one was giving a big discrepancy between the training and the testing, and at some point I just said, the logistic one seems to be much closer, and I just stuck with that one for the most part.
Yeah. Turns out that a lot of times you're time constrained when you're doing these kinds of projects. Not necessarily in this way, but like you wouldn't have an hour to do one of these kinds of projects, right? But even so, the kind of things we're going to get into with data sets that of the size that we're going to look at, trying things sometimes tuning these models is going to take, or training these models is going to take an hour. And if you've got to do that a whole bunch of times on a whole bunch of different things, it very quickly becomes time prohibitive. So that's certainly one part of it. Didn't necessarily have time to do it. Dennis?
Yeah, so my read on the boosted trees is it seems like it wants to do excursions to do something more like what Ryan was drawing up there.
Mm-hmm.
And so, I mean, I was looking back in so the training set, I think I got that right. The training set got really, compared to the other ones, got really good, whereas the test set got worse because as it makes the trend line more complex, the data that's being used for tests is going to get worse and worse and worse.
Yeah, because what's happened here is that it's learned all the noise, right? Any data generally consists of two components, right? And we see this whenever we write down a line for a linear equation. Y equals ax, plus, or a plus bx is how I'll do it, plus some error term. This is generally how we represent a linear regression. We have signal, and we have noise. Something that we can learn and model, and something that even in principle we can't learn and model. I mean, in principle is a little bit of a funny thing here because, up to the uncertainty inherent in quantum mechanics, presumably we could model all things at a fine enough level. But for practical purposes, there are things that we just can't predict. For example, a coin flip. If you have a model of coin flips, there's 0% signal, 100% noise. Any model that you learn that does at all good on training data has just learned the noise, right? So when we learn this noise, it's not going to be replicated. And if we try to apply what we've learned to the noise to new things, we're going to have problems. And that's what that boosted tree model did. It also turns out that boosted tree model is the best model in that notebook, if you can get it to work right. It's very powerful. And we're going to see that it ends up being the state of basically what everybody uses for spreadsheet-like data, which this is spreadsheet-like data. It's effectively, the state of the art for spreadsheet-like data. And I doubt anybody submitted it as their final model, right? Did you submit it, Will?
No, but are there exceptions for spreadsheet-like data where this wouldn't, and are there certain data fields or ways of looking at data that this wouldn't be the route that most people would go with?
We'll talk more about that, but the short answer is when you need to extrapolate, tree-based models don't do very well extrapolation.
Okay.
But for data where you're primarily interpolating, tree-based models this gradient boosted tree, XG boost, tends to be what everybody uses.
Okay.
But with that power comes incredible complexity, right? Lots of knobs to tune. My guess is that the reason you couldn't bring it back is because there are too many things going on at one time. Now you could plug and chug for a while, just try a whole bunch of different things, and eventually you get that tree to work. But it'd take a whole lot more time than you had. So one of the challenges as we go forward is going to be figuring out how to let the computer do more of that plugging and chugging. So what kind of models did you guys generally find that you submitted? For your final submissions, your best submissions, what models were they generally?
Random forest.
Random forest?
Yeah,
It's a
random
lot of
forest.
regression.
Was this regression? Random forest? Anybody submit a regression tree? Yeah. I'm not surprised. Those models are kind of, in some sense, a little too simplistic to ever capture interesting relationships. But it turns out there are useful building blocks for other things, including wisdom trees. All right, that's enough about the modeling component. What else did you guys notice as you were going through the exercise? Right?
When you just pick all the variables as opposed to like 1 or 2, then your score goes up.
Okay.
And then from there you sort of work your way down and try to hack away useless variables.
Okay, so you used all of the variables, and that caused your score to go up.
Yeah, because before I was trying to do like 1 or 2 at a time,
Uh-huh.
and I was getting scores like 0.1, but then when I did everything, it just dropped to 0.2.
And so then what did you do to continue improving your score?
I like eliminated one of the variables, like that I just intuitively thought this wouldn't make any sense, and then see if it went up or down.
Gotcha. And so then you work backwards. So you eliminated variables after this. It's almost like you were mining the data, trying to extract relationships. Yeah, I mean, so you start with everything, and it can be a useful approach to see just what happens to be useful there. What happened to be useful in this data?
Say it again.
What was useful in the data? So Brian just proposed kind of this try everything, see what was valuable approach. So the question is, what was valuable?
And which variables?
Which variables? Yeah.
Yeah, wheel type is pretty important.
Wheel type. What is wheel type?
Alloy or missing.
I believe there's 3 values here, right? Alloy.
Covers, that's all in the description. That's it. Just alloy and covers.
Oh, there's covers, and then
No.
okay. So this was an important variable. Sam, you said it was an important variable. Anybody else find this is an important variable? Okay. Why?
Well, I don't want missing tires or missing wheels or.
So wait, so what does missing mean here? You said
Sorry,
missing.
null each chunk of the information on
Okay. So we had alloy, covers, and null, which just in my data cleaning phase I filled in with the word missing, meaning missing data, right? Okay. So what was important about this variable? Which category was predictive of a bad car?
Isn't it null? I think.
It
Right? Is
was
that what we
it
can-
was missing for wheel type ID. I didn't check for wheel type.
Oh.
Turns out those are the same variable. Wheel
Oh.
type and wheel type ID. One is a numeric coded version of the other.
Okay, yeah, then it was missing.
So it's the exact same thing with wheel type ID.
Okay.
And it was when wheel type ID or wheel type was missing